Tá bom. Beijo.
All right, good morning. Happy Wednesday. Everybody should have your homeworks returned. Please let me know if I missed you. I don't think I did.
I received homework 2, but not homework 3.
I know, I'll send it right now. Anyone else?
Same. I didn't get homework 3.
I don't know what my problem is. Sorry. So everyone else can be sending me questions to answer. That'll be great. And we psyched for Friday.
Yes.
I sent yours. Just a couple comments on homework 3. When you're doing a continuity problem, you want to use the definition of continuity, right? Use that process of, okay, find the value of the function, find the value of the limit, make sure they match, and then state some conclusion. There's a couple of little notation things that are strange, and then the rest are just simple algebra mistakes. So, you know, just be, be patient, work quickly, but try and be organized, and make baby steps every time you do a new line, and if you factor something, double check it, and et cetera, right? Everyone got homework returned, correct? No, I got there, good. Yes, Mark, send me a picture of it, please. If you have a question you want me to do, please send me a picture, okay? It just makes things a lot smoother. You have to go to one place and send me something. And if several students ask me a question, I have to go to 7 places, right? So if everyone could just send me a picture of the problem they want me to do, preferably with your work, right? But if you didn't work on it yet, that's fine.
Professor, are you gonna do a squeeze theorem today in the review?
I can do another one, sure. Yeah.
Okay.
I plan on putting one on the test, right? So I figure whatever you ask, I'm talking to everybody, whatever you ask me will chip away at what I still feel like I should talk about, right? So ask away, please. Johan, you got your homework from me now?
I got it, thank you.
Yes, thank you, sorry.
So I have a question about the squeeze theorem. So when we do the squeeze theorem, we have to find the values of both, right?
You have to find say again?
We have to find the values of both. We can't just use one value. Like, we have to find the value of both.
I'm not sure I'm getting what you mean, but you're saying that it would turn into a limit of a product, and you'd have to find the limit of both products?
Okay, so squeeze theorem is just making sure that the greater and lesser value.
Yes, but the only squeeze theorem questions I will ask you are, knowing that the limit of sine x over x as x goes to 0 is 1, find this limit, right? So the only thing I could possibly ask you is, right, something like knowing the limit as x goes to...
Professor, your screen.
Thank you. Sine x over x is 1, right? Knowing that limit. Find the limit of cos x minus 1 over x is 0. Right, so that would be a typical question I would have to do. Now, what am I looking for? So I'm never asking you to squeeze with functions. I think that's what you mean now. Would you have to find a right-hand function and a left-hand function and find the limit of both of those? I'm not going to ask you to do that. Okay. So this would be a very fair problem to do. So what do you want to do here? How do we find limits? What's our process?
We can use derivative.
Yes, I could do L'Hopital's, but in this case, I'm only saying you can do this, right? So in this one, I'm saying I want that to show up in your solution. So if you do L'Hopital's here, you'd get what? Sine x over 1, right? Or sorry, minus sine x over 1. Yes. So if I did this with a hop, right? I would get what? I'd get limit as h goes to 0, x goes to 0 of cos x minus 1 prime over x prime, right? Yes, you with me? But you'll see I won't get this, I'm looking for this green box to show up, right? So what do I get here? I get the limit as x goes to 0, wake up, of minus sine x over 1. And of course that can be evaluated right away, right? 0, sine of 0, and that's 0, right? So if I said to you, solve this limit, show this limit as 0 using L'Hopital's, right? Done. But I said, show it with this squeeze limit that we know, right? And who's got the idea for me? What am I putting in here? I need to put something in here. What is it? Who's got the big brain on today? Tell me, how do we do limits? That's our very first homework. What kind of limits do we do?
Algebraic.
Yeah, so I can't factor anything, so that's out, right? There's no fractions within fractions, so that's out. What was my last? Conjugate. Do you see a conjugate here? Yeah, you see a conjugate here, right? So I've got what, cos x plus 1 over itself, right? So what do I get upstairs now?
Cos squared x.
Cos squared.
Nice, cos squared x minus 1, right? All over x times cos of x plus 1. Now there's an identity you know from upstairs, right? You know a trig identity from upstairs. What is it?
Sine squared x.
Almost negative sine squared x, right? 1 minus cos squared is sine squared. So if I have it reversed, I've got a negative sine squared. Now you can see I've got a factor of sine x upstairs and a factor of x downstairs. So that's what I was looking for, right? So I'm ready to go back to my limit, right? So the limit as x goes to 0 of star is now the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of everything left over, which is minus sine x over cos x plus 1. Right? And so that first limit is 1. That's what I was looking for, right? And the second limit I can plug in, right? So minus sine of 0 over cos of 0 plus 1. So that's what? 1 times negative 0 over 2. And I'm just being silly there. Of course, you could just see that that's going to be 0.
So Professor, we just do well, in theory, even though it's a squeeze theorem, we just do the same thing that we do with limits, and we just transform in the way that.
Yeah, you're looking for that specific limit, so you gotta try and make it happen, right? Like I think I had done one earlier. What I had tan of 2x over x, right? And then we had turned it into what? Sine 2x over x times cos 2x, right? And then I can see the upstairs becomes 2 sine x cos x over x cos of 2x, right? You remember doing this one? And I'm splitting that into my sine x over x times 2 cos x. Sorry, yeah, 2 cos x over cos 2x, right? And there's my piece again, right? I had done that one earlier this semester. So I'm just gonna, twist my mustache, try and think of some evil problem to make you find that factor in there, right? And you can see all of these things I'm doing right now are on past exams. So make sure you've looked at all of them, right? How's the form? Go ahead.
The question for this would be prove that tan 2x over x is like equal to 2 cos x over.
No, knowing, and I'm going to write it just like this, knowing that the limit of as x goes to 0 of sine of x over x is 1, find the following, right? Find the limit as x goes to 0 of tan of 2x over x, right? That's the question. And then this is you starting to work on the function, right?
And the answer,
Finding-
and yeah,
Yeah,
and the answer would be 2 cos x over cos 2x, right? Guess.
no, take the limit, then take the limit, so you get to 2,
Oh yeah.
right? Yeah. That's what I thought you were saying before, Noam, that, all right, I know I got the sine x over x is 1. Do I need to get the limit of the other piece that's left over? Yes. Morning, nice to see everybody. Marcus, did you send me the picture of the problem?
Yes, I did.
Okay, thank you. Oh, I got it, yes. Shimaka sent me one too, thank you. Who is on the iPhone with no, it just says iPhone? Who's there? Knock, knock. Who's just on their phone today without a name on the screen?
iPhone.
Hello, iPhone. Shouldn't it be Siri? I guess. I hate Siri.
Hello, that's me, Professor. That's
Oh, Jesse T, thanks. No problem. No problem.
my laptop's not working right now.
Uh-oh, what are you gonna do for Friday?
No, it's gonna be fixed. It's gonna be fixed.
Okay, all right.
Professor,
Yes, Pedro.
can you review later with me like my homework because I don't know what I did wrong on 10.
Yes, I've got 2 other questions, and then we'll take a look at your homework.
Okay, thank you.
From homework 2, correct?
Yes.
Yeah, okay. So this is a problem from Shimaka. This is a great problem to do. I want to find, so if f of x equals 4x over x plus 1, find f prime using a limit, right? So this is a quotient rule, right? So you know the quotient rule now, so you could certainly double check that you have it right? You could do that. You could graph it. iPhone's a lovely person, leave him alone in the chat. So you could graph the function, graph the tangent line at a point in the domain, right? So you could pick anything but x is -1 here, right? So there's lots of ways for you to know that you got this particular problem right, okay? But let's do the limit because that's what I'm going to ask you to do on the test, right? So I know that f prime of x equals the limit of 4 times x over x plus 1, but instead of x, I'm putting in x plus h, right? And then I'm going to subtract off the original function, all divided by h, and I'm doing this limit as h goes to 0, right? So that's what I want to see. You don't have to put this on, but it does make it pretty clear that I'm doing that limit of that, right, that complex fraction. So I like to work on that on the side, right? So I'm going to say this is the limit of star as h goes to 0. And I'm just going to work on star, just trying to be organized, right? There really is punctuation here too. I'm saying that this is the thing I have to do, and now my next sentence I'm saying, hey, let me simplify star as much as I can, right? So I like to do these fractions. I like to clear out as much of the parenthesis as I can as I'm starting this problem. And here, I like to wrap any multi-terms total. So I'm kind of just rearranging my parenthesis here so that I can see, right, that LCD, right, which is x plus h plus 1 times x plus 1 all over itself, right? So that LCD over itself. Mr. Malgahouse, this is, right, this is what we wanted to go over, correct? Yeah. Yes, nice. So I'm gonna distribute the purple to the numerators, right? Distribute the purple to the numerators upstairs and the numerators downstairs, right? So I'm gonna try and keep all the original in black and distribute in purple. So I like to space out when I do these, which is kind of a joke, because I don't want to space out, I want to stay focused. But I'm trying to get myself set up, right, for this distributing. So x plus h plus 1, x plus 1. I think quite a few of you are pretty confident about this process. There's a couple of you still doing weird algebra, just from this past homework that I passed back. So be careful with your algebra, right? And then there's weird notation a lot. I like to really, instead of keep writing limit, I like to go to a little bit of a side work to work on everything as much as I can. But here, I can clearly see my x plus h plus 1 factor cancels there, and my x plus 1 factor cancels here, right? And I am really doing the double lines for the first factor, triple lines for the second factor. I'll do quad lines for the next factor, just trying to really be able to see what I did. If I had just one cross out on everything, I mean, no, I've been doing algebra for so long, right? So I'm just trying to stay organized. Now I'm rewriting and I'm trying again, baby steps, trying to do baby steps. So 4x plus 4h, x plus 1 minus 4x times x plus h plus 1. And again, my focus is upstairs because that's where my fractions cleared. So I'm going to try and not do other pieces. I don't really want to distribute downstairs there. It's not wrong to do that, but it won't make your derivative easy to find. How we doing here? So if you looked at a couple of my old midterms, you would see, hey, find this derivative using a limit and check it with the quotient rule, right? But for you, I'm not going to say that because the quotient rule is going to be on our second test. So I'm distributing here, and I'm really trying to be careful when I'm distributing, right? I'm trying to really make sure I'm taking my time. I'm looking at all the pieces, right? And then the last one is just a 4h. And this one's pretty easy, right? This one doesn't take as much concentration. And again, I'm trying to write a complete sentence every time. And again, I'm looking for things to cross out. And what's my little thing I have memorized? If the pieces without a factor of h all have to go away, some terms with a factor of h could go away, right? But I have to be able to cancel that h downstairs, right? So I see my 4x squared go away, my 4x goes away, my 4hx goes away, and all I'm left with is something with a factor of h in it. That's what I want. So I think this is, well, it's almost there, right? This is 4h over h times x plus h plus 1 times x plus 1. And then canceling my h's, and I finally have a nice version of star now, right? 4 over x plus h plus 1 times x plus 1. And I don't think this is too slow. The speed I'm going, I'm talking too, so I'm right. You're having these thoughts in your head, right? Or you're talking out loud. I guess you could. You're gonna, right? No one's gonna hear you. And if you are talking to yourself out loud, I'm gonna mute you. So, but I'm ready to take my limit now, right? So the limit as h goes to 0 of star I don't have to write that again because I can take the limit. It's right there on the page, so I can just take the limit. It's 4 over x plus 0 plus 1 times an x plus 1. Okay, well, that's obviously the same factor twice, right? But I can just make sure I'm careful about it. And I've got 4 over x plus 1 quantity squared, right? And I can then say f prime of x is 4 over x plus 1 quantity squared. I mean, it's if you get the problem right, who cares about checking it, right? But if you get the problem wrong, and then I say to you, did you check it? Obviously you didn't, right? So, you know, so you really should be getting things right because you know how to check them all, right? Do you want to do this with the quotient rule, or do you want to do it with the tangent line? Do you want to do a check here with the quotient rule? Or do you want to do a check with the tangent line?
And really the only tricky part with that version of doing that limit is just keep working upstairs after you expand the fraction of everything else.
Yep. Do we want to do a check here?
Yes, you
Which
did.
one?
Question
Which
one.
one? Quotient rule, fine. Quotient rule's pretty quick, right? What was it? Y equals, I forget already, x over, no, 4x, right? 4x over x plus 1. So upstairs function is 4x, derivative is 4. Downstairs function is x plus 1, derivative is 1, and the downstairs squared is x plus 1 quantity squared. You can already see my downstairs squared, right? You can see in my answer the derivative, that x plus 1 quantity squared. So I really just have to see if the upstairs gives me 4, right? So what do I get? 4 times x plus 1 minus 4x. Oh, you can definitely see it, right? Right, what do I get upstairs? I get 4x plus 4 minus 4x. So done, right? Done. I already know it. I know the 4x's go away.
Can you do the tangent line, Professor?
Say again, Marcus?
Can you do tangent line right now? Tangent line.
Oh yeah, sure. So what looks good for my domain? What number do you want to do? So I would say graph the function right away, right? So what do I know? I know y equals 4x over x plus 1, right? So I want to graph that right away on my calculator and then pick a point in my domain that I think is good, right? And it's kind of subjective, of course, but it's nice when you get to be a little creative. So even though I'm using my Desmos, you're using your calculator, but I want to see that picture real quick. Y equals 4x divided by x plus 1. And if you kind of remember, this was like on that homework from section 2.1. So like, I don't know, 3 looks pretty good to me, right? So I'm just looking at it and saying, well, you know, where should I pick? Doesn't matter, right? It should work for any point in the domain, so anything but -1. So let's do at x equals 3, what do I get for y? Y equals 4 times 3 over 3 plus 1. So I get 3, right? So it's nice. I have to point 3 comma 3. And I have to get the slope at 3, right? So f prime at 3. Where's my derivative again? Thank you. 4 over 3 plus 1 quantity squared. So it looks like 1/4. So I've got everything I need now, right? I am putting a tangent line on your test with what kind of function? What kind of function am I putting on your test?
And it's the cosmos.
Yep, some trig, right? Some trig function. so y minus 3 equals 1/4 all times x minus 3, right, for my tangent line, yes? So this is my setup, right? Setup for the problem, checking with the tangent line, and so I'm setting everything up for the tangent line. I need a point and slope, right? I get y minus 3 equals 1/4 x minus 3/4. So I'm gonna put that 3 on the other side. It becomes positive and becomes 12/4, right? And what do I get? 9/4. So there's my tangent line, y equals 1/4 x plus 9/4. Is that correct? Yes. And then I'm graphing that. What's nice about me picking that particular point is I can see that it hits, you know, I call them vampire points, like I'm holding up a cross to scare a vampire away, right? Where I see it hits a integer, right? You know, because probably not going to bother graphing the point on our calculator, but there it is, right? And then I had y equals 1/4 x plus 9/4. There it is. And it should be really clear. Right? Nice way to check. I mean, that check is going to work more often. You know, because, well, I'm not going to give you 2 quotient rule problems. So, right. Nice. Mark, go ahead, Mark. Go ahead, Nahum.
Yeah, no, Professor, you can finish because it's just another question that you could.
Yeah, no, I'm done. That's it.
Okay, so, Professor, can you do spring 2020 number 5?
Yes, send it to me, please. This one is coming from Pierre, Markins, and oh, so I kind of just did this one, didn't I, at the beginning of class? So this is from I can't tell where it's from, Marcus. Which one is this one from?
Isn't spring 2020 number 5?
Okay, spring 2020, number 5, nice. And it's a I don't think I even need to do it now, but I'll talk about it real quick. Again, it's a knowing the limit as x goes to 0 of sine x over x is 1. Find the limit as x goes to 0 of, I think it says sine 3x over 5x, is that correct? Plus 1 minus cos x over x, right? So I did this one already, right? I did this part of the limit already today. Yes, everybody agreed? I remember I did the conjugate, right? So I don't need to do that part. So let me just do the other one, okay? Let me just do the other one. So let's just pretend that the problem just says this, the limit of sine 3x over 5x, right? So we're doing the limit as x goes to 0. Markins, you in agreement with me on that?
Yes.
Okay. So this is the limit as x goes to 0 of star, right? So I'm going to just work on star a little bit, right? So I have a couple choices. There's not a great identity here for me to do. I could do a trig identity, right? I could do a trig identity if you really had to see that. I could do a theta substitution, right? Or I could just use some funny versions of 1 anytime I wanted, right? So I think the quickest way is to multiply by 1. So I'm going to say that this is 1/5 of sine 3x over x, which is 1/5 times 3 over 3 of sine 3x over x, which is 3/5 times sine 3x over 3x, right? So now you see my argument and my denominator are the same. Sine of theta over theta, sine of x over x, sine of 3x over 3x, right? So this piece is obviously going to go to 1. I just got to make one little change, right? Right? I'm just going to let theta equal 3x, right? So if I say theta equals 3x, right? We know as x goes to 0, theta goes to 0. As x goes to 0, so does theta. Right? Theta goes to 0. So I can say the limit as x goes to 0 of star equals the limit as theta goes to 0 of 3/5 times sine of theta over theta, which is obviously 3/5. Right? Once I get that particular one, it'd be kind of cruel for me to ask you to do it with a trig identity, but I'm like kind of thinking like I should have been teaching like that the whole time, right? So let's see what happens if I do it with a trig identity.
Yes, now, so where did you get like 1/5 from? Like,
It's just the 1/5. You see the 5 downstairs?
yes.
So that's really a factor of 1/5, right? Right. If you
Yeah, what about you do it 3x, like in the sine?
well,
thing?
so
you
I'm
just-
trying to get my argument of the sine function to match the denominator. So I can't just multiply the denominator by 3. I have to multiply the top and the right. I have to multiply by 1. So I pick 3 over 3.
So like sine 5x over 5x would also like equal 1.
Exactly. As x goes to 0. Exactly.
Okay.
Let me show you with the trig identity. Okay. Upson, what's up?
For the last step, because we said x equals 0, and then that's equal to theta equals 0, but in the last part where you have 3/5 over, times sine of theta over theta, would that, do you want an extra, is there supposed to be an extra step where we have like sine 0 over 0? Or
Yeah,
like,
yeah. So we know. Yeah, sure. I could have done this, right? Maybe it's better. So the limit as theta goes to 0 of sine theta over theta, and now we know that piece is 1, and then there's our 3/5. So yeah, like I would prefer the more details, but I would. Yeah. Let me do this
Wait,
other way. I have a feeling. Go ahead. Yes, Chimaka.
So do we have to include the theta? Can we just like do sine 3x over 3x equals?
Well, here's the problem is if I'm saying use this, I want to make that substitution somewhere,
Okay.
right? It's like, I just want that to show up in my work, right? And so I finally had it show up here, right? And that's the trick on these problems.
Okay.
Yeah. I mean, I like this. I'm starting to think that this is the way I'm going to ask you to do it, but I know I'm going to freak a couple of you out, but it's better to freak you out on review day than on test day. So if I say star is sine of 3x over 5x, right? I can do the identity of sine of x plus 2x. This is a nice way to do it. And then I have this formula on my, right? I have this sine of alpha plus beta, right? So this is what? Sine of alpha cos of beta plus cos of alpha sine of beta all over 5x. And so this is kind of nice. This is a nice way to do it. I might just ask you to do it this way. So I've got now a sine x cos x over 5x. Okay, I see what I want there, right? Do you see it? And on the other one, I've got a sine 2x cos of x over 5x. I don't quite have what I want there, but I'm going to make it happen, right? So my first one, I have sine x over x times cos of 2x over 5x. And the other one, I have a sine 2x. That identity is 2 sine x cos x times another cos x all over 5x. And again, you can see what I want, right? You can see that sine x over x there. So now I have sine x over x plus cos of 2x over 5x. By the way, times, right? Over 5, by the way, right? Plus sine x over x times 2 cos squared x over 5. And now I've got it shown up twice, right? It's a pretty nice way of doing it. So if this is star, the limit as x goes to 0 of star is the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of cos of 2x over 5 plus the limit as x goes to 0 of sine x over x, I could have factored, times the limit as x goes to 0 of 2 cos squared x over 5. And now all of these turn into 1s, and the rest can be just done, right? So 1 times cos of 2 times 0 over 5, which is 1/5, plus 1 times 2 cos squared of 0, which is again 1 over 5. So it looks like I get 1/5 plus 2/5, so 3/5. Like that way.
So,
That process is much easier.
Professor, I have a question.
Yes.
Yeah, it's really, yeah. I mean, no, my question was, is it required to do all these steps? Because you could have just got the answer straight if you, like, when you go up, like, so you could go up, you could just say, wait, can you go up, Professor?
Yeah. So let me give you numbers. Where are you saying I can skip?
Oh, yeah, perfect. Okay, so you can just say, sine 3x over 5x equals to sine x, sine x over x multiplied by 1 plus 2 over 5, which is basically 3 over 5. And you could have got that answer. I'm not mistaken.
Write it down. Send me a picture of what you're saying.
So like number 1, the line, like you from the beginning. Sine x, sine bracket x plus 2x over 5 is basically this equals to sine x over x multiplied by 1 plus 2, because when you expand sine x plus 1 plus 2 becomes sine x plus 2.
I need you to write it. I need you to write it down and take a picture and send it to me. Right now, on a piece of paper, take a quick picture, send it to me, okay? Because
I have a question on number or step 4. Yeah, line 4. I thought when you separate sine x over cos, when you separated the denominator, why is it x times the 5x? Shouldn't it just be 5?
Yes, that's a mistake there. Thank you. And I fixed it down here. I realized it down here, and I was writing the x again, and I realized, no, I didn't need it. Thank you. Well, I tell you, you're ready for the squeeze problem. It's 1 problem out of 10, and we've done 4 of them. So you're ready for this one. Please stop asking about the squeeze. I want to do a continuity one, unless someone has one they want me to do.
Professor, on the first step is sine 3x, the first part?
Mm-hmm.
Okay.
Sine 3x, yep.
Yeah, I was thinking, Professor, like if we just simplify the x out, would we get like 3/5 for the answer in the first step?
No. So sine 3x does not equal, and if anyone writes this, I will curse and jump up and down, and right, these are not equal. And this is what I think Nahom is trying to do as well. You cannot do this, right? Sine x, 3 sine x is the sine function with an amplitude of 3, right?
The other is a frequency of 3.
Yes. And the other one is a frequency of 3. So that means I'm going to see, right? I'm going to see the sine curve 3 times there. So 1, 2, 3, right? So they are not equal.
Yeah, I get that. But what if, like you say, like sine 4x over 5x? What would be the answer?
4/5. I'm not saying that the
Yeah.
I'm
Like
not
if you give
saying
me
the problem isn't
Yeah.
easy. It's easy, right? But
Yeah,
can you
if
show
you give
me?
me if you give me a problem like sine 4x over 5x, like
Yeah,
I think the answer might be like 4/5, right?
yes, but what if you get it wrong and you don't show me any work? I'm not grading you on the answers as much as I'm grading you on the work. If you do all the work right and then have a wrong answer down, I'm gonna write, well, did you check it with the table, right? You know what I mean? There's no reason, but it's about you, right? I've taught you all these rules to poetry and or these ideas, and then I'm asking you now to write me a poem. If your poem is 4/5, not much of a poem. Still cool, but all right. Pedro asked me a question.
So, but if I'm not mistaken, I think when reading the book, it said that you could do this too. I'm not mistaken.
So could you send it
Because
to me?
oh yeah. Okay. Do I send it with chat or email?
Send it to me, please.
With email?
Yeah, you take a picture of what you just wrote down and send it to me. I'm gonna look for Pedro's work because Pedro doesn't want to send me photos.
I can resubmit because like just reply again to my own email. If
No, but I don't want to look at the whole email. I want to look at the one question you want me to do.
it's like
Don't worry, I got it. You okay with me showing it on the screen? Or do you want me to put it on the other screen?
No, that's okay.
I'll put it on the other screen.
Yeah, but that's
I'll put it on the other screen.
okay. Is the first one the second one that like, yeah.
Hold on, please. Trying to move it to my other window. It's number what?
Is the number 5 and the one after that.
Number 7.
Yeah.
You didn't do the limit. You did the shortcut only. You didn't do the limit. You only did the shortcut.
Oh.
Noel asked for, and let me, Pedro, I'll go back to yours in a second, but I still think we're still talking about this. How did I stretch? Yes. So this is an identity. Right here and here is an identity. Sine, the enumerators. Sine of alpha plus beta, this should be on your formula sheet, right, is sine alpha cos beta plus cos alpha sine beta. Right, you should have done that in pre-calc.
And like all the sine and cosine formulas, that is one of your classes that you posted. Like you haven't like in one of your classes you put it out the formulas in one page. So
Yes.
like if you want to copy the formulas, you can just go back to one of your recordings.
Yeah, just look in the book.
Oh yeah.
The first page in the book is blue, and the cosine identity, the trig identities you need are in the back of that page.
Oh.
And so, Nahom, it's the same issue. So you're saying to me sine of x plus 2x, and it's not. It's the sine of x over x times 1 plus 2. This thing is not a factor, right? It's not a factor, right? The trig is a machine, like a soda machine, okay? And the inside, I'm trying to get our pictures back, here we go. The inside is unknown to us, okay? All we see is, right, the outside of the machine, sine. And the inside is where the argument is, okay? So that can't be factored out, cannot be factored out. Yes, you with me?
Yeah, okay.
Yeah.
Just figure it out.
So I can't do this. Can't do this at all, right? And that's what I had just said, right? What was the one before it where I had, right? This one. You cannot do this. They're not equal. You cannot factor something out of that piece like that. All right, Pedro. This is good. This is all good stuff. I think we're cleaning up some things, and that's good, right? So Pedro, I had given you y equals square root of x. I want you to find y prime using a limit, right? Find y prime using a limit, and you did the shortcut. And so I gave you half the points. I was feeling generous that day. So y prime is the limit as h goes to 0. A square root of x plus h minus square root of x all over h. And I'll call this the limit as h goes to 0 star. You with me? So I've got star as square root of x plus h minus square root of x all over h. And I am going to use the conjugate. Right? My conjugate is going to be square root of x plus h plus square root of x. And because I can only multiply by 1, I want to divide that conjugate by the conjugate. Pedro, yes? So I get x plus h minus x all over h times, right, that conjugate. So it looks like I get, nice, h over h times the conjugate.
You add negative x square root of x, so it will be plus square root of x.
Thank you. No. It's negative, right? The formula is, remember, difference quotient. So difference quotient, and then it's the conjugate, right? So when I multiply the conjugates, I get a negative again.
I think it means the one.
I'm thinking about, yeah.
Where? Oh, yes. The conjugate turned to negative. Sorry, you're right. Thank you. Thank you, Marcus. And so there it is. There's star. I've got 1 over the conjugate, right? And I'm ready to take my limit. So y prime is the limit as h goes to 0 of star. And I get 1 over square root of x plus square root of x, right? The h is 0. So there it is, 1 over 2 square roots of x. I think one of the biggest problems I'm seeing in the homework is you're not reading directions, right? If I say include a graph, include a graph. If the book says include the domain, include the domain. So you got to read, okay? And there's a little bit of a disconnect going on. And I think it's mostly from not reading what the problem says, or not reading the additional instructions I add, right? Or some of you looking in the wrong spot for the homework. Look in the textbook. Don't look in WebAssign, right?
I just sent you another one that I know we've gone over before, but I was trying to follow the key and with my work and I couldn't get it.
Yes, let me take a look. Yeah, so this one, right, I did in class, but I'm not going to ask anything like this. And this is my work, right?
Yeah.
So you said you tried it but made a mistake somewhere?
Well, I tried mine and then I got at a like point where I had to stop, and then I went to yours to like check my steps, but I couldn't follow yours.
Yeah, so on the first line, no, I started with cos is bigger than x is bigger than tangent, right?
Mm-hmm.
But that is, that's different than what I had.
Yeah, I think you said at the middle part, like you said, oops, and
Yeah.
then you put.
Oh, yeah. It should have been, it's almost right in the middle. Needed to start with sine x bigger than tangent, but it's actually not true either, right? It's tan is bigger than x is bigger than sine is what it really should be, yeah. So I'm sorry about all that confusion, but tan is bigger than x, which is bigger than sine.
Mm-hmm.
So if you start from tan x greater than equal to x greater than equal to sine x, then it should work. So start there if you want to try it one more time, but I wouldn't bother. I did it right. Yeah, I did it right in the lecture. I think that is in my chapter 2 review, isn't it?
Yeah.
Yeah. I don't know how many years ago I made a mistake and I'm just too lazy to fix it.
But it's not in the text, right?
No.
Okay.
And this is more this theory behind the squeeze problem, right? So we're now on at least 30 minutes of talking about one problem. You're going to be fine on that problem, right? In fact, I just gave it to you, honestly. I gave you the cos of alpha plus beta. I'm going to do something like that on the test. All right, I want to talk about some continuity.
Yeah, before I go to continue, Professor, can you do number 11 and spring 2020? I just send you the picture.
Yeah, good.
Thank you.
If it's a squeeze problem, I'm gonna screen.
Actually gonna squeeze?
This is good. This is a continuity problem, right? So let's actually do this as our continuity problem, and then I'll add this last piece, right? So this is spring 2020, number 11. Is that right, Marcus?
Yes.
Yeah. Nice. Is this the last question on the test?
Yes.
Yeah. So this would have been an extra credit, just so you know, because it is a little tricky. But I have my original function of e to the x plus x, where x is less than or equal to 0, and 1 plus sine x, where x greater than 0. And so the question is it continuous at 0, right? Well, what do I have to check? Well, I have to check the value of the function, right? Step 1 is f of 0, and I'm going to use my first machine, right? Everyone agree? I'm using my machine I'll call y1, right? And this other machine is y2, right? Why am I using that machine? Because that's where the equal sign is on the 0. So I get e to the 0 plus 0, which is 1. Everybody with me? So for checking continuity, I have to check, does the function exist at the point? Yes. Good. I now have to check the limit, right? And I have to check that the limit as x goes to 0 from the right of my other machine, 1 plus sine x, right? And that is just a plug in, so that's easy. This is 1 plus sine of 0, so that's 1. And then I have to check, do they match, right? So since f of 0 equals the limit as x goes to 0, right, of f of x, which is 1, the function is continuous.
On the homework, was
Yeah.
there something wrong about my notation?
Did I write what?
You wrote. I forget what you wrote. Let me check.
I think I wrote use the definition of continuity. When you do continuity problems, and this is why I'm doing one, because I noticed on the homework, you just got things all. I'm not talking just to Alan or everybody. You got stuff all over the paper, but I gave you a process. Check the value of the function. Check the value of the limit. Make sure they match. Tell me what you got. Right. So I know for a lot of you I said conclusion and took a point off. Or a lot of you, I said use the definition of continuity, or
You wrote f of 0 and f of 1 on my paper, and then.
yes, because you never actually showed me that it existed at the.
Oh, okay.
You never, yeah. So you never.
I just read the
showed
limit.
me-
I get it.
Exactly. You just did the limit part. Yeah.
Professor,
Yes.
I get the conclusion and the process, but at the very beginning you said like y1 and y2 and then like use the machine. Can you explain that?
Yeah. So what I'm saying is, like normally we would say f of x is like, let's say 2x minus 1. That's
Mhm.
my function. That's my machine. This particular function, right? Like a car, a toaster, a machine, has two pieces, and I'm
Yeah.
supposed to use one piece. Right? It's like the clothes cleaning machine. It's the washer and the dryer. Okay. So at first I use the washer, and then I use that. So that's what I'm saying. I have two machines here. Which one should I use when?
So you wanted the one where it exists.
Exactly. So at 0, when I plug in a 0, I need the equal sign. So I have to use
Okay.
that.
Okay. I don't have to do it for both.
What's that?
We don't have to do it for both because I remember when we usually do
No,
continuity.
this one I need a limit, because remember it's really close to 0, but from the right.
Mhm.
Yeah. And I can see myself using maybe L'Hopital's in a limit there when I ask you about continuity. So you would find the value, good. You would go do the limit, and the limit would give you 0 over 0, and then you got to do the limit anyway, right? And so anyway, unless I tell you you have to do it one way, you could do it anyway. But L'Hopital's will be quickest, of course, if it's 0 over 0.
Professor.
Yes. No.
Yeah. Sorry. Can you go back to the squeeze theorem question and basically the addition like formula question?
Yes. Let me finish this one. Okay. So this was not the question. This was an extra credit question. It says is f of x differentiable at 0? So this is the extra credit part. Is f of x diff at x equals 0? There's the extra credit piece. So it's continuous, right? If it was not continuous, then it's definitely not differentiable. Yes, do you agree with that? What does differentiable mean, first of all?
Different?
No.
You can see
The slope is the same.
The slope, yes. So it's got a slope there, right? And yes, Jesse, where you're going with that is the slope from the left has to be the same as the slope from the right.
Yeah, the skis don't tip.
Exactly. So, but why do I need continuity? I have to, if I'm skiing, right? I have to be able to stand on the hill at that point to measure the slope, right? If there's a hole there, then the class is over, the teacher's dead. Those are skis, right? You got a broken arm. So if there's a hole there, I can't measure the slope of the skis, right? I've fallen through, yeah. So I need it to be continuous in order to be differentiable. So if it wasn't continuous, then it's definitely not differentiable, right? But now let's talk about differentiable. It means I'm going to get derivatives on each of these. What is my first derivative?
X.
E to the x plus.
Well, for e to the x, it's just e to the x plus 1.
E to the x plus 1. I'm going to use that slope machine for x less than or equal to 0. And what's my other derivative?
Cos x.
Cosine
yeah,
x.
for x bigger than 0. So my slopes at 0, right, from the left, right? So m at 0 from the left is what? It's e to the 0 plus 1, it's 2, right? And my slope from at 0 from the right is cos of 0, which is 1. Are the slopes matching?
No.
And so it's not differentiable.
So it's continuous but not differential.
Yes, continuity does not imply differentiability, but differentiability does imply continuity. If I have the same slope, if I'm standing on the hill and I can calculate the slope, I gotta be standing on a point, right? That can't be a hole in the ground there. No home. Please.
And then if
No,
this was for the test question, you'd right at the very end, not well, if they were equal, you'd write they are differentiable at 0,
Yeah,
or
sometimes,
if they
yeah,
weren't, then
I
they
wanna
are.
I want to read the paper and know we're having a conversation, right? Right. I just
Yeah.
don't want a bunch of numbers on the page. I mean, yes, I can still decipher if you got it right or wrong, but I want it to be a poem. I want it to be elegant, right? All right, Nahum, I'll give you 2 minutes. Go. What's your question?
Oh no, I get this. I think. Yeah. So we use the addition formula. So my question. So Professor, once okay. So for the sine, the x plus 2 parts. So we use addition formula. Before we do that, can we basically divide them both and then make sine x plus 2x x plus 2x over 5x equals to sine x plus 2x multiplied by 1 over 5, and then we use the addition formula, and then we could just plug in.
I think you're cheating the sine function again. I cannot tell. I can't really.
Well, no,
And he's talking about the outside quotient
What line am I? Where am I looking?
on 1.
On line 1. I can't do anything until I simplify that numerator.
Yeah, so what I meant is, so we could do sine x plus 2x over 5x equals to sine x plus 2x multiplied by 1 over 5.
No, because then you have a sine squared. You got to write it down for me. I'm not catching what you're saying. What I'm hearing is no, you can't do that. But if you write it down for me and send it to me, we can talk right after class. Okay, I don't want to spend any more time on it. Let's look at our list.
Professor.
Go ahead, Jesse.
I think he's doing something
I don't
similar.
I don't want to spend any more time on it. Pedro.
Right.
Yeah, just like when we have like sine 3x 5 like over 5x, we can always like if we have like 3x 4x,
Pedro,
we can.
Pedro, I don't want to spend any more time on it.
It's like with the simplification
Pedro,
we can.
I don't want to spend any more time on it, please.
It's not about like the solution.
I don't want to spend any more time on it.
Can we just go back for a look, just because I want to squeeze? The squeeze theorem part. The squeeze theorem.
No, after class. Okay, I want to just go through the list real quick and see if there's anything anyone wants me to talk about anymore. Okay, I'm going to do probably 2 limits, right, with conjugate or LCD or factoring or combination of 2 or 3 of those, right? So 2 limits algebraic, right? And then the same 2 with L'Hopital's, right? I want to do at least 2 functions, 2 derivatives, right? 2 derivatives using a limit, maybe 3. One that you'll be able to check with a shortcut, and one that you would need the chain rule to check it, right? But instead of checking with the chain rule, because it's so new to us, we only did it Monday, you could check with a tangent line, right? I'm going to do definitely 1 tangent line with a trig. Okay, 1 tangent line with a trig function. My other class, I did a quiz with tangent line and a trig function, and they couldn't tell me what sine or a cosine of minus 5 pi over 4 was. So please make sure. I mean, you know, you have a calculator, you have a formula sheet, you know. You're supposed to have either tested out a trig without cheating or taken the trig class, right? So make sure you can do those. I'd like definitely a continuity problem, but 2, 4, 6, 7. I'm thinking maybe 2 continuity problems, maybe not, right? So let's say 2 continuity problems. So one where I'll just say, is this continuous, right? Right, so I'll say, is F continuous? Or find numbers to make the function continuous, right? Just
we
like
could check graphically, right, Professor?
Of course, yeah. So find A and B and R, so the function is continuous, right? What is that? 2, 4, 6, 8, 9. Pretty damn close, huh? Oh, and the squeeze, right? Like the one we spent so much time on today, right?
Professor, can we use like the unit circle?
You can put anything you want on your formula sheet. You can put inspirational lyrics. You can draw pictures of happy bunny rabbits. I don't care. Anything you want on that formula sheet.
It's still front and back of one paper, right?
And the edges, all 4 edges too. I'll also allow a magnifying glass. They just got a magnifying glass. I think that's it. I mean, I'll do anything on here that you want me to do except for a squeeze problem. Anything on here except for a squeeze. Anything we got?
Find second continuity
nice.
problem type.
I like
Yeah,
that.
I was about to say.
Yeah. And I
That was the only one I'm not comfortable
if you
with.
didn't use the definition on the first homework 3, first problem, I may have taken a point off, but if you didn't do it again, I didn't take a point off. So I try not to punish you for repeated errors. You know, it's like a cop turning on the lights behind you and they say, well, I've been following you for 5 minutes and you've been speeding, so here's 5 tickets. No, 1 ticket, right? Let me grab one problem from a previous test. and then we'll be done for the day. I think you're ready. I think you're ready. You asked good questions today. We cleaned up a lot of little mistakes. What?
Can you also do the tangent with trig function?
Yeah, if I have time, I can do that too. Yeah. I think I did that one with this class. Let me pick a different one. Yeah, this one's good. I can't remember which one I did. It doesn't matter. Oh, I didn't record it. No, I didn't record today. I'm sorry, forgot.
Unfortunate.
Yeah, come on. You all know how to do these problems. So here's
Yeah, that's fine.
I probably did this one already, but just so that you can see the notation again. So I'm using e to the x if x is less than 1. I'm using ax plus b if x is between 1 and 3 inclusive, and 9 minus x squared. Did I do this one? If x is bigger than 3? It's okay if I did it, because what you really need to see here is how I want the problem answered. Nothing's difficult here, right? We certainly can draw this picture quite quickly, right? E to the x, right? 9 minus x squared. I think that's a parabola. And then I'm connecting with an mx plus b. I'll do, I've done it a couple of times using just pick A and B, just find A and B and get the equation on the line. But I want to do it again where I'm going to use the definition, right? At x equals 1, I want to find f of 1, right? What do I get there?
E?
Yeah. No, I get 1a plus b, right? I got to use where the equal sign is, right?
Oh, yeah. That's right.
Yeah. Now, so that means at 1, I need the limit of the function there, right? Well, I already know the limit of the function from the right is a plus b, right? So I want the limit as x goes to 1 from the left, of the function. What part of the function do I use? I want e to the x, right? But that's just e, right? So what do I know? I know from these two, right? So step 1, find the value. Step 2, find the limit. Step 3, make sure they're equal, right? Step 3, make sure they're equal. So I know a plus b has to equal e, right? I do the same thing at 3, right? At x equals 3. What do I get for f of 3? It looks like I get 3a plus b, right? I still have to use the machine that has the equal sign there, right? The part of the function that has the equal sign. And what do I get for my limit? I get my limit as x goes to 3 from the right of 9 minus x squared, of course, which is 0. So what do I get for my third line, right? I get 3a plus b equals 0. And I've got to use those two as a system of equations to solve for a and b. So a plus b equals e, and 3a plus b equals 0. So if I subtract them, what do I get? I get negative 2a equals e, right? So a is negative e over 2.
really quick, just to you said 1, 2, 3. You went. You find the limit, you find the value, and you set them equal. Right? In that order. Oh no, you're muted now.
First step is find the value of the function. Second step, find the limit. Third
My
step,
bad.
show the
Okay.
right, yep. So I've got A, how do I find B?
Place it in the equation.
Okay.
Well, I put it into either equation. It looks like it might be easier in the second equation. So 3 times negative e over 2 plus b equals 0 gives me b equals 3e over 2. All right, how much time do I have? Perfect. Just and then conclusion, right? And graph. Well, I did my graph first, but right, you want your graph to look continuous. So conclusion, I'm not going to write it. I'll just say it. With a equal negative e over 2 and b equal 3e over 2, we know the function is continuous, right? Or you could rewrite the function, right? You could say f of x equals e to the x negative e over 2x plus 3e over 2, and then 9 minus x squared, right? Yada, 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 yada is continuous, right? Any way you want to say it. Be creative, be elegant. Six, 8, 12, 15. I had 16 students here today. I'm missing, oh my God, what the hell's going on? 6, I'm missing 6 students. Okay, oh yeah.
They were sleeping.
Yeah, let's do tangent line. For y equals sine x at x equals 7 pi over 6. All right, well, I got an x value. I need a y value, right? So y is going to be sine of 7 pi over 6, right? 7 pi over 6 I know is in quadrant 3. All students take calculus. So I know sine is negative there, so it's negative sine of pi over 6. So it's negative 1/2. And certainly if I'm drawing my sine function out, right, I know I have critical points at pi over 2's, right? And it should make sense that at 7 pi over 6, I get a negative value here, right? So this is the point, 7 pi over 6, comma, negative 1/2. And I want my tangent line. So I already know something about my slope, right? My slope should be negative. My b value should be positive. How do I get my slope? Y prime is what? Cos of x? So m is cos of 7 pi over 6. This is a gift, this problem, isn't it? Cos is negative there, so negative cos of pi over 6, right? In quadrant 3, cos is negative. And what is it? Square root of 3 over 2. So there's my slope. So I have a slope and a point. I'm ready for my tangent line, right? So y plus 1/2 equals minus rad 3 over 2 times x minus 7 pi over 6. How are we doing here? Is this freaking anybody out? Any trig haters here?
Yeah. Why did you change 7 pi over 6 to pi over 6?
Well, that's how I do trig. So you know, if you're using unit circle, you don't do what I do.
Okay.
Yeah, so I don't like the unit circle. So for me, I'm just going right, cut pi into 6, which means cut the whole thing into 12. Find the seventh one, but that's got the same ratio as the first one, the reference angle. Pi over 6 and 7 pi over 6 have the same ratio, but a different sign, SIGN. And I get my signs from all school teachers' curse, right? In quadrant 3, only the tangent is positive, everything else is positive.
Yeah.
Everything else is negative, sorry. But you do your trig the way you do your trig, okay? You don't have to do your trig the way I do mine. And then there's my final answer. And I'm just doing arithmetic here. You don't have to do your arithmetic the way I do mine, right? And there it is. And of course, you're going to graph it. Nice. All right, I can't wait to see what you do Friday. Try and get in a little bit early if you haven't shown me your phone view.
Professor, the calculator can graph this.
Sorry?
You said like after we get this, we graph it.
Yeah, I graphed it before I even got the answer,
yeah.
right?
It's just a really rough sketch, or like we need a.
What I have is perfect. And then, right, so in black, I've got y equals sine of x, right? I've got my point.
Yes.
In red, I have y equals minus rad 3 over 2, x plus, I forget, 7 pi rad 3 minus 6 all over 12, right?
Mm-hmm.
Done.
Oh, okay.
But you're doing it on your calculator to make sure it's right.
We can plug it in, yes?
I'm sorry, what?
Yeah. No, I was like mostly talking to myself because it didn't.
Oh, and the calculator, your y1 is sine of x, your y2 is your tangent line, right?
Sine of x. Okay, first I write my sine of x, and second I wrote this 3 over 2x 7 plus
minus square root of 3, yep, over 2 times x, yep. The only thing you'd have to watch out for is that you have this wrapped. Just make sure you have that piece wrapped.
And okay, done. Really quick, the world's potentially quickest question. Can you do like super simple, write a really quick limit, and then as algebraically, and then just compared to L'Hopital's?
Yes, I can.
Doesn't need to be complicated at all.
Okay, I can do that.
Just so I can see the method.
But class is over, so I want to make sure everybody knows they can go. You certainly can stay. So I'll see you Friday.
Thank you, Professor.
Thank you. So let's see, limit, right, is x goes to -2 of x cubed plus 8 over x squared minus 4. Right? So this is the limit is x goes to -2 of star. And we'll do it algebraically first, okay? So star is x cubed plus 8 over x squared minus 4. That's x plus 2 times x squared minus 2x plus 4 all over x plus 2 and x minus 2. So star is x squared minus 2x plus 4 all over x minus 2. And I can get that limit by plugging in. So -2 squared minus 2 times -2 plus 4 all over -2 minus 2. So it looks like I get 12 over -4, -3.
Yep.
Same thing with L'Hopital's, right? So this is algebraic. And then we'll do one with L'Hopital's, yes? Take a little hop. So the limit as x goes to -2 of x cubed plus 8 over x squared minus 4. I get a 0 over 0. So I'm going to do the limit as x goes to -2 of x cubed plus 8 prime, right, derivative, over x squared minus 4 prime. And I get the limit as x goes to -2 of 3x squared over 2x. I like to simplify it. I could just plug it in. I just like to simplify it if I can. It looks like I get 3/2 times x. Right, so that's 3/2 times a -2, which is -3. Same answer.
It's a pretty beautiful way of solving the question.
Yeah, it's nice, right? I don't wonder how much you paid for it.
It preserves like the structure of the original function, and then you just kind of do a part here, do a part there, and then get the answer.
Yeah, pretty easy. It comes in useful in Calc 2 also, you'll see.
Yeah, especially because you know the shortcuts by then as well.
Yeah, hopefully. Yeah.
Thank you, Professor. See you on
All
Friday.
right, nice. I'll soon see you Friday. You're ready. How can I help? Anything else?
You still haven't checked my, my setup and everything.
Oh yeah, do you want to do that now? It's fine.
Okay, and
Yeah, you can come
how
back.
does that
I'll wait for you. You can come back in on your phone.
I did like do Zoom on my phone?
Well, someone has to watch you. I'm gonna watch you take the test. The test will be on the. Are you sitting in front of a computer right now?
Yeah.
Yeah. So you'll be taking the test on that computer. You'll need
Okay.
something else to watch to take the test.
All right.
So that could be a phone. That could be another computer or whatever.
So that's really it?
Yeah. And I should be able to see your. So I'm gonna move my phone here. I'm gonna move my camera. Sorry if I'm making you sick. I want to be able to see you, your computer. You can see the class on the computer screen. I want to see where you're writing. I want to see your formula sheet, everything, right? I should be able to see everything.
I'm gonna go out to the car and get one of those arms that holds my phone.
Exactly. That's why
I'm gonna steal one from one of the cars.
No, don't steal.
Well, I'll give it back after.
Okay. All right. Oh, it's your family's car.
Yeah, we have like 2 or 3 of them.
On the algebraic way, how we go from x 3 plus 8 to...
I personally use synthetic division, so it's pretty clear that -2 is my interest, and I have a 1x cubed, 0x squared, a 0x, and an 8. So I'll use my synthetic division. I'll bring down the 1, multiply, add, multiply, add, multiply, add, and I see the coefficients here of 1, -2, and 4. Right? You see the matching of the coefficients. There's a 1x squared, there's a -2x, there's a +4.
And the one, like, you cancel like the x plus 2. The x plus 2 is like it will be there? How?
So since x equals -2 is a 0, right?
Yeah.
X plus 2 is a factor. This is all pre-cal stuff, right? So x equals -2 gave me a 0, right? So that means x plus 2 is a factor.
Okay.
Let me get something for the setup. So I might do it tomorrow, like early as possible. If that's okay with you?
Yeah, Friday is early. Yeah, I'll be in probably around 10 of.
All right.
I'll be in early on Friday.
Okay.
Nice.
So like around like what, 7:30?
I'll be in like 10 of, I think. I'll try and be in at 7:30, but I can't guarantee.
7:45.
Yeah, 7:45. Okay.
Okay.
It'll be
All
fine.
right.
All right.
Thank you,
thanks.
Professor.
All right. See you Friday.
You too.
Professor,
Thank you.
what's the difference between I forgot, the shortcut and the algebraic way? Just like just by word, like. What's the difference
Well,
between?
the main difference is that when we first started the class, we didn't know derivatives yet, right? So we couldn't do a limit using a derivative. I needed limits to be able to figure out derivatives. And then I realized, I learned, we talked about L'Hopital's rule, you need derivatives. So now looking at all these limits, you can see that all the derivatives are simple.
Yeah.
So, yeah.
The shortcut use derivatives, yes?
L'Hopital's rule, yeah.
Okay.
No, yeah, shortcut, yeah, we just memorized, right? We memorized if y equals square root of x, y prime is 1/2 square roots of x. But the shortcut there is really that I'm using a power rule, right? I get y prime is bring down the power, reduce the power by 1, right? And so that's really the shortcut, the power rule.
Okay. See you, Professor. Bye bye.
All right, see you Friday.
Yes, Professor. And my homework, like,